In this video, we are going to solve Cambridge O Level with the code paper 5054, paper code, and paper 1, variant 2, May, June 2025, which is the most latest paper over there. It is 1 hour paper having 40 MCQs questions, which is shown here, multiple choice question for paper 1 over there. All right, let's move towards the solution. And remember that the weight G value is 9.8 Newton or 9.8 meter per second square. Which we're taking 10 ms minus 2 for the previous papers over there, but right now he is going towards 9.81. The total marks of paper is 40 and each correct answer will score 1 mark. Any rough working should be done on this question paper, not anywhere else over there. This document has 16 pages. It's okay. Okay. Which list contains only vector quantities? Vector quantities are those which have their direction over there. For example, vector is a force. Vector force is right, left, up, down, having any direction specified over there. It is a vector quantity. And on the other end, for scalar, I will define that, for example, speed, for example, work or pressure. They have no proper direction. They just need the magnitude and unit only. Here, mass and distance are scalar, weight is vector. He said only vector quantities should be there. Momentum, gravitational field strength, and displacement. So here the gravitational field strength, momentum is vector. Gravitational field strength is scalar and displacement is again vector. After that, energy is scalar, force is vector, velocity is vector, acceleration, time, and speed over there. In that case, which list contains only vector quantities? I will say here that momentum, gravitational field strength, and displacement are all vector quantities. Gravitational field strength is showing value of positive G when it is going downward. It is showing negative G when it is going upward over there. Momentum is a vector quantity that can be clockwise or anti-clockwise over there. Displacement is the shortest distance between 2 points. Here, energy is not vector. Here, time is not vector. Scalar is not vector. Here, the distance and mass are not vector. But in option B, all the quantities are vector quantities over there. The diagram shows the distance time graph for moving object. Okay, distance is covered and it means when it has reached at this point, it is coming at rest. Description of the moving object over there. So description. Okay. Now he is saying a ball is thrown vertically upward and falling back to the thrower. Back to the thrower. Then he is saying a ball is thrown vertically upward and falling, means upward is going, and then at rest, it is at rest, it is not coming down. This is, for example, I say he is getting the speed to getting low because it is distance time graph and its gradient gives the speed over there. If I say speed is decreasing because the gradient is decreasing with the passage of time. So if he is going vertically upward, then falling back is not shown on the graph over there. A car starting from rest and speeding up and moves away from the traffic signal. Now, then the distance should not be finished over there because here he is saying it is coming to rest over there. A rock is dropped from the high cliff and falling into the sea below. Then I'm saying that speed should not be getting zero again. A train braking to a halt as it stops a station. That's fine because we can say when the train is applying brakes, he is at point t is equal to 0 at that instant, and gradually he is decreasing its speed and coming to rest at the station. So option D is fine for it. For the question number 3, let's check what he is saying over here. He is saying the speed time graph of a falling skydiver is shown. As he falls, the skydiver spreads out his arms and legs and then opens his parachute. The speed time graph for a falling skydiver is shown. As he falls, the skydiver spreads out his arms. Okay, he has opened his arms and legs and then opens his parachute. Which part of the graph shows the skydiver falling with the terminal velocity over there? So that is the constant velocity, and this is the speed which is coming like in this form. Then we can say it is going to be shown by D. Speed is not decreasing. Speed is not increasing at any point. Speed is coming at a constant speed with the parachute. When the parachute is open, then the skydiver is coming with a constant speed that is called terminal velocity over there, with which it is falling down. Okay. Here he has shown a car driver traveling at a constant speed for the X over there in a straight line, sees a hazard in the road ahead at time t is equal to 0. Like this is his thinking distance. And the time graph shows that this three students suggest what the X and Y represents. Student 1, X represents the thinking distance. Student Y represents the stopping distance. Student 3 is saying that area X plus area Y represents the stopping distance over there. So I will say here that when we say Y represents the stopping distance, because this is not a complete stopping distance representation over there, then I will say thinking distance and braking distance both should be included. Thinking distance plus braking distance is equal to total stopping distance. For that case, I will say here option Y represents the stopping distance, not only this. I will go with student 1 is saying X represents the thinking distance. 3 says X plus Y is the stopping distance. So option B will be fine for it. The diagram shows the graph of load and extension. Okay, it is related to elasticity over there, in which he is saying the diagram shows a graph of load against extension for a material, at which point is the limit of proportionality. So proportionality where the graph is straight line over there, and we can say here that as when extension of a material is being taken and limit of proportionality is taken, then the graph should be straight line between load and the extension. So point A is showing the graph straight line over there. After that, it is little bit curved, then again curved, and then again shown over there with the different names. This is called yield limit, ultimate tensile strength, and breaking point over there are shown. So option A is fine for limit of proportionality for this question. There is no atmosphere on the moon. Okay. Two metal spheres, there is no atmosphere on the moon. There are two spheres of identical volume but different mass at the rest, at the same height above the ground on the moon. The two spheres are dropped at the same time. How do the spheres move after they are dropped over there? The spheres with the larger mass has smaller acceleration, but there is no atmosphere. Only gravity is acting and freely over there. Larger mass has no acceleration over there. Smaller acceleration, no, because they both have the same acceleration over there. After that, he is saying the sphere with the larger mass hits the ground first. No way, because gravity is constant. On the moon, it has the value of 1.62 meter per second square. So 1.62 is G value on the surface of moon over there. The sphere with the smaller mass has the smaller acceleration. The two spheres hit the ground together. This will be fine. That there is no atmosphere, no upthrust is acting on both of these objects, even they have larger mass or smaller mass. There will be no effect in that case. So not to worry about it. Just say they will fall with the constant speed over there and hit together at simultaneous points over there. A student determines the density of a small rock. The weight of small rock is 1.2 Newton. So the best method is to go first to get its mass over there, because we know that density is equal to mass over volume. So your mass is W is equal to mg. M is equal to W over G. if I take approximately equal to, we can say 1.2 divided by 9.8, as he said over there. Let's check what is the value over there. Okay, he is saying here 1.2 divide 9.8 equals to this equals to 0.122. 0.122. This is the mass in kg. And in case of volume, she pours 100 cm water in a miring cylinder. She fully submerged the rock of in 100 cm cube of water. The new reading of my cylinder is 147. So we can say 147 minus 100 will be 47 cm cube will be the volume of that rock. In that case, I will say 0.122 divided by 47. Then we can say 0.122 divided by 47 will equal to 6 over this will equal to 2.6 multiply 10 raised to power minus 3. And if I want to convert it, then this gram into this kilogram, because it is in, I have taken this mass in kg. If I take in gram, then it will give me the answer, which will be given as 2.6 over there. So answer D is fine for it. After that, he is saying that a rock of mass 20 kg is traveling in a space at a speed of 6 meter per second. Find its kinetic energy. And you know the formula of kinetic energy is equal to half mv square over there. So it is half m is 20 into 6 square over there. So 2 into 10. 20 into 36. So it is 360 joules over there is the right answer for this one. Okay, now he is saying which row shows an advantage and disadvantage of using nuclear fuel to generate electrical power over there. So in that case, we will say does not produce carbon dioxide. He is right over there. Produces radioactive waste, disadvantages. So I think so this option is perfectly all right. Does not produce carbon dioxide, only works in some weather conditions, because we know radioactivity is never going to be discovered by any environmental condition. So it is not right. Energy source is renewable. No, produces this. Okay, energy source is renewable. So not renewable, and not in weather conditions. So these are wrong. And option A is perfectly all right for question number 9 over there. Let's go to question number 10 now. Okay, in 10, he is saying which row gives the definition of the work done and the unit of work. Unit of work, we know joule can be the energy transferred per unit time. That is called power. So it is not the right option. Rate of change of energy is called power, or energy transferred per unit time is called power, which is having the unit as a watt over there. So it is not going to happen. Energy transferred per unit time is also power and having not unit Newton per meter. And Newton per minute meter is unit of spring constant. Spring constant. Okay, the force multiplied by distance moved in the direction of force. This is the definition of work and joule. So option C is perfectly all right. The force multiplied by distance moved in the direction Newton per meter should not be taken over there. That can be Newton meter, because force into distance, force Newton and the distance meter. Newton meter can be used, but we use that unit for moment. That is the turning effect of force, or vector quantity over there. Okay, a hammer hits the nail into a piece of wood. The weight of the nail is negligible. Okay. The hammer exerts a force Fh on pressure pH on the nail. The nail exerts a force Fw and a pressure Pw on the wood. How does the forces and pressure compares over there? All right. In that case, where he has given us about this complete scenario, then we say that Fw, the nail which is exerting the force over there, should equal to we can say hammer is having, like, as we know, the formula pressure is equal to force over area. Then I will say here that the hammer force will completely be transferred to nail towards wood over there. So option 1 or 2 is going to happen, the true values over there, 1 or 2. But the greater than, like, wood is having greater force, this is not possible over there. The force exerted by the nail is greater. No, it's not possible. On the other hand, when we go for pressure, as we know, the area is decreased in case of nail, and when I look towards hammer, the area is larger over there. In case of pressure, if I am decreasing this area in the form of nail over there, pressure will increase. So pressure of wood should be greater than pressure of hammer over there, because area has decreased, and according to this relation, we can say pressure and area are inversely proportional to each other. So option A is fine for it. Pressure of wood is greater than pressure of hammer because wood is being exerted by a pressure of nail area, that is a pin area, pinhole, pin of that nail, which is being inserted inside the wood over there. After that, he is saying the pressure at a point beneath the surface of a liquid varies with the depth of the point with the density of the liquid. We know the formula pressure is equal to rho GH. Rho is density, G is gravitational field strength, and H is depth of liquid. Which changes both increases the pressure beneath the surface of a liquid over there. Then we can say, if I will observe the formula, pressure is directly proportional to density, pressure is directly proportional to gravity, pressure is directly proportional to height of this value. So which changes increases, both increase the pressure. So depth decrease, so it is directly proportional to P is directly proportional to height. And if change in depth decreases, pressure will decrease. But here he is asking increase. So decrease, both option gone over there. Increase of depth and density is also directly proportional to pressure over there. Then you should not take decrease over there. So right option is only D over there. In both cases of density and change in depth will be taken. Then we can say pressure will increase if I increase both of these values. The diagram shows a cylinder container of air. Okay. The piston is free to move. Okay. This is the piston which is free to move inside the cylinder, and atmospheric pressure acts outside the cylinder over there. As the air inside the cylinder is heated, the pistons moves towards right because the pressure of air inside the cylinder increases, which quantity decreases. So he is asking which quantity decreases over there. He is saying here the average force exerted on the piston each time that one air particle hits the piston. The average speed of the particles, which quantity decreases. This is increased, this is increased. The mass of air inside the cylinder decreases. The mass of air inside the cylinder. No, it's not possible. The number of collisions made by air particles with the piston is going to increase over there. Yeah, that is fine. The number of collisions made by particles should decrease so that piston in 1 second over there, the air inside the cylinder is heated, the piston moves to hit to the right. Which quantity decreases? Number of collisions per second going to decrease over there. Now he is going towards the relation. Okay, a fixed air of mass volume V1 and pressure P1. The volume of the air is now changed to 100 cm3. The temperature of the air remains constant. What is the new pressure? Use the relation P1 V1 is equal to P2 V2 over there. So keep the P2 as it is, and P1 is 120. I'm not using kilopascal over there because kilo is also required in this form. That will be cancelled out. No problem about that. And V1 is 150 over 100. So two zeros are gone with 1 and 2. I have only 15 multiplied 12. So I will say here 15 multiplied 12 equals to 180. So that is 180 kilopascal, which we will say here is option B over there. P2 is equal to 180 kilopascal. Let's move to this point. Oh, that's nice. This is easiest MCQs in the paper, by the way. The diagram shows four changes of state W, X, Y, and Z. Gas, liquid to gas is W. W liquid to gas is, we know, condensation. So option A or option B can be going on. X. X is melting. X is going from gas to liquid. Liquid to gas should be boiling. I'm wrong. Not should be taken because we know liquid is going to gas, that is boiling. And gas to liquid is condensation. So boiling and condensation is given. For Y, solid to liquid is melting. Solid to liquid, Y, melting. So option D will be fine over there. And option for Z, it should be freezing because liquid is going to be converted into solid. Here I also am writing the names of the processes: liquid to gas, condensation, gas to solid, freezing, gas to liquid it is, sorry. It is gas to liquid. That is gas to liquid. Liquid to gas, I have written wrong, guys. Liquid to gas is boiling. Gas to liquid, condensation. Liquid, solid to liquid. Solid to liquid, melting. Liquid to gas, solid, freezing. Over there. So the diagram shows a metal pan on the hot plate. Okay. The pan is heated by the hot plate. How is the thermal energy transferred from the hot plate to the metal pan? So hot plate to metal pan should be going that there are, we can say, solid particles. They both are solid and both have the vibratory motion of their particles and free electrons also available. So in solid, we say the mode of transfer of heat in which energy is transferred to the adjacent atoms due to vibratory motion of those atoms over there. Because hot plate is also solid and its metal plate is also solid over there. So that is conduction is going to happen over there. Mode of transfer of heat in which the energy is transferred from one end of the particle, one end of the solid to the other end due to vibratory motion of the particles over there or free electrons over there. That is called conduction over there. A beaker of cold water is heated at its base. What happens to the heated water over there? Then we can say uh, density of heated water will decrease definitely because it will become in the form of getting heat and molecules are going away from each other, it will decrease. And movement of heated hot water will be going upward and cold water will come downward. And this cold coming down and hot is going up. This is called convection current over there. So in both of these cases, I will say here that heated water density decreases and it is moving upward over there. This is related to convection currents. Okay, now he is moving towards the waves section of the paper. The graph shows at one instant the pressure variation along the sound wave. pressure variation along the sound wave. Okay. Pressure and distance. Which of the diagram represents the refraction and which wave, what is the wavelength of the sound? So wavelength is being taken in the form of x over there. The distance between two consecutive crests or troughs. If I make a trough over here, then if I take this point like that, then it can be the wavelength over there. So X is fine for it. X. Two options are there. Then he is saying which should be rare fraction should be shown over there. So in case of rare fraction, I will say here that it is going towards minimum value that can be shown by with the help of Q over there. So option C can be taken as X as wavelength and Q as a rare fraction. Rare fraction means when, for example, I am speaking right now, and when I'm taking pause between the words, then rare fraction is going to happen. And we can also discuss over here that what is going on in next. Let's move towards question number 19 over there, in which we can say that we are going to take this value. Okay, question number 19 states that we are discussing about it. A cork on the surface of water moves up and down as a wave process across the surface. The diagram shows how the height of cork above the level of the surface varies with time, and height is given 2 centimeter up and 2 centimeter down, and time period is given according to 0.5 seconds far as time period of the wave, and the numerical value of the wavelength is of this wave is equal to the numerical value of amplitude of this wave. What is the numerical value? Wavelength and amplitude are equal. Then we can say what is the wave speed. So we know the formula for wave speed is V is equal to F lambda, in which I can say the formula is V is equal to F lambda. And we need speed. And frequency, for frequency, I will use F is equal to 1 over T. Reciprocal of time period is equal to frequency. Then I will say 1 over 0.5. And when I take it 1 by 2, 2 is coming up. So it is 2 hertz. And the wavelength which he said over there is equal to amplitude, which is 2 centimeter over there. So I will say V is equal to 2 into 2, which is equal to 4 centimeter per second over there. So option C is perfect for this answer over there. Okay, now if we move towards question number 20, let's check what is he saying over there. A water wave travels from deep water to shallow water in a ripple tank. Okay, from deep water to shallow water. So what happens to the speed and to the wavelength of the wave? Remember that the formula V is equal to F lambda have 3 variables into it. And when we are observing that the object is moving from deep water to shallow water over there, then the speed will decrease. And wavelength for this one will decrease also because frequency remains constant. And I will say here wavelength will also decrease in that case because both are directly proportional to each other. So when from deep water they are coming to shallow water, both will decrease over there. So option D will be fine for it. According to this formula relation I have used to show that the frequency remain constant and only wavelength and speed are being going to affect it over there. Okay, here he is saying the diagram shows ray of light. It is the light topic, okay. Mirror is being shown with the 40-degree. What is the angle of incidence and angle of refraction? I will show you here that if I draw a normal at this point and this refracted ray is also making 40-degree angle on this side, and normal and surface are having 90 degrees. So 90 minus 50 is 50-degree here and 50-degree here, because according to laws of reflection, angle of incidence will always equal to angle of reflection over there. So both will be 50 over there, and option D is fine and perfect for it. Okay. Okay, a ray of light is in glass is incident on the surface at an critical angle over there. All right. The angle, critical angle is the angle C is critical angle, which diagram shows what happens to the light. So light will not refract, light will not go straight. Light will not being shown the total internal reflection over there. Light will be reflected towards 90-degree by making with the normal over there. That is called critical angle. Such angle of incidence is called critical angle, whose angle of refraction is 90-degree with the normal in this direction, will be called critical angle over there. And option D is going to hold for this answer over there. Here he is saying an object O is placed between a converging lens and an principle of focus of the lens over there. Converging lens and focus lens. Okay. Here he is saying what is the magnification of the image over there formed. So when we place the object between the focal point and the center of lens, we know that the image formed will be virtual and on the same side over there. Then I will say here that the ray which should be passing over there in this form, and the ray is passing from here to principal focus. If I am increasing both of these waves, then where they are going to intersect, use the proper scale over there, okay? And increase this length also. There will be a point where they are going to intersect over there, and the magnifying glass or magnifying glass which we use in the biological lab over there, to magnify it, we will say here that they are going to produce the same phenomenon. So this is the point for where they are going to meet, and our upright image, virtual image will be produced. And if I just look at them, the original height for small box was 1 centimeter. So it is 2 centimeter and it is increased up to 3 times over there. Magnification will be like 6, as I show you here. This is 1 time, this is 2 times, this is 3 times. So approximately it was coinciding at this point, and then I'm saying the magnification will be taken as 3, because according to definition of magnification, size of image to the ratio with size of object will give you the magnification of this object, and it will be 3 times, or 3 will be the magnification of this image over there. Which statement about red light and violet light is correct over there? So, which statement? A prism deviates the red light more than it deviates the violet light. So if I look towards prism and white light is entering and it is showing a complete spectrum over there, then I observe a red deviates, red is at top and violet is at blue, and red shows less deviation from its original path over there. So this is not right. Red light has lower frequency than violet light. Yes, he is right. Because whenever you are heating up an iron rod, what will happen? The first color which iron will attain, that will be red. And the last color of visible light spectrum which that iron rod will get, that will be violet color over there. Red light has shorter wavelength. No. The speed of red light in vacuum is less than no, because light is going with only the same speed in the vacuum over there, that is 3 multiplied 10 raised to power 8 meter per second for all the electromagnetic waves. So it is not going to hold. So he will say here option B is correct according to the statements of the questions over there. Ultrasound is used to clean the jewelry in a liquid. What is another use of ultrasound over there? So, optical fiber communication. No, we use light over there. Parental scanning over there. That can be done. Parental scanning means pregnant woman is being detected with the help of ultrasound technology and checking about the health of a baby over there. Photography, no way. Telephone communication using the microwaves or other communication signals in the form of light over there. Okay, a ship that is stationary on the surface of sea, okay, sends a pulses sound vertically downward towards the seabed. Means I am saying this is a sea and ship is resting over its surface and it sends a signal to the bed of sea and signal is detected back and each pulse that reflects from the seabed is received in 1 second. Means 1 second is the time with which it is being traveling towards and coming back. The whale swims under the boat and a pulse is received 0.6 seconds as it is sent out. Means there is a whale and it is reflecting back with 0.60 seconds. The speed of sound in the seawater is 1500 meter per second. What is the distance of the whale above the seabed? What is the height? So I will have to calculate both of the distances over there. And then in that case, I will say distance for bed is equal to speed multiplied time divided by 2, that is 750 meter, and the height which the whale is getting after 0.60 second, then I will say here then it is 1500 multiply 0.60 divided by 2. Let's check what is the answer coming over there. That is 1500 multiply 0.60 divided by 2 equals to 450. So 750 minus 450 will give you the depth of that distance, that how much whale and the seabed are far away from each other. Then it will be 300 meters over there. So option A is perfectly all right for this answer over there. After that, question number 27, which row describes ultrasound waves? Ultrasound waves are having the frequency which is greater than 20,000 kilohertz, which is not in audible frequency range, and greater than 20 kilohertz is fine for option B and D over there. On the other hand, he is saying towards that types of waves is longitudinal or transfer. So it is longitudinal. So option B is perfectly all right for it. That longitudinal plus greater than 20 kilohertz. And the audible frequency range is 20 to 20 kHz. And below is infrasonic and above is ultrasonic over there. And that is ultrasound to be taken into account in that case. A quantity is defined as the work done by the source moving unit charge around a complete circuit. Okay, means work done by a source in moving unit charge. That can be a source over there. Then it will be EMF, electromotive force over there, and a whole circuit over there. And it will be measured. This electromotive force is a voltage, is a potential difference like quantity over there. So we can say it is going to be taken as electromotive force measured in voltage or volts. And its formula is EMF is equal to work done per unit charge or energy supplied by the energy source in moving a unit charge. A unit charge, he is saying you can take K, Q, epsilon naught or Q naught over there as a unit charge. And this is EMF definition properly over there. After that, he is saying a student connects the circuit as shown in figure 3666, okay. And he is saying the switch S is closed. This switch is closed over there, okay. What is the reading on the voltmeter over there? So for the voltmeter reading, I will have to, voltmeter is connected between the point where 6 volts should be taken over there, and it is 6 ohm opposite only. So it is 3 ohm. It is 3 ohm. It is 6 ohm. Why I have taken this 3? Because I know that 1 over R total is equal to 1 by 6 plus 1 by 6. And total resistance which will be taken over there will be uh, 6 as LCM and 2, and then reciprocating it towards 1 over R total to R total will give me 6 over 2. That will be 3 over there. So I have taken this overall parallel resistance can be taken as 3 ohm over there. And in that case, I will say here that we will have to go for voltage to be taken onto account. Then these two, like 3 this, total 6. So 6 and this separate 6 are going to divide their voltage over there. Then if it is total 6 volt, means 3 volt is coming towards this composite. I am going to add to get the total resistance of 6 ohm, and this is also getting the 3 volt over there. So option B will be perfectly all right for this answer over there. Okay, here he is saying that two resistors connected in series act as potential divider as shown. The resistance R1, voltage V1, and R2, potential difference with V1 and V2 themselves respectively. Which expression is equal to V1 over V2 is equal to V2. As we know that resistance and voltage R is equal to V over I is also being shown as directly proportional relation according to Ohm's law over there. So I will say here that V1 over V2 is equal to I R1 over I R2. So I is gone. So R1 over R2. So option A will be perfect for it. And I have done this according to Ohm's law for getting its values of ratio for the resistances over there. Here he is saying that what is this happening? An electrical current of 1.5 ampere for 4 ohm resistor. Okay. How much energy is transferred to thermal energy in 1 minute? So as we know, that energy is equal to power multiply time, where the power is I square R. In case of electrical power, I am taking this formula into T. So I square 1.5 square into R is 4 into time is 1 minute, means 60 seconds. Let's check what the answer is coming over there. That is 1.5 square 1.5 square multiply 4 multiply 60 equals to 540 joules. So it is 540 joules, which is option C over there. After that, let's check what he is asking in the next question over there. A square coil is placed in a horizontal uniform field, magnetic field, okay, from left to right, showing the direction over there. The plane of the coil is perpendicular to the magnetic field. Okay, the coil is now rotated about the axis through P at a steady rate. The coil is rotated through 180 degree. Okay, which diagram shows how the electromagnetic force is induced in the coil as varies with the in the coil varies as it rotates through 180 degree. So I will say here that angle of rotation going towards this rotation over there, EMF will be shown by its peak value in the form of DC, because coil rotates through 180 degree every time over there. So 180 degree will not show 50% positive, 50% negative, will not show complete cycle over there, will not show the straight line over there. So option A will be fine, that it is showing its positive sinusoidal waveform during the first 180 degree. For the next one, if it is AC, then it will be negative. If it is DC, then it is going to straight over there. Three pieces of equipment is made. Electromagnetic materials are listed: the core of transformer, the needle of compass, iron fillings used to show the magnetic field pattern over there. Which pieces of equipment act as temporary magnets when in use over there? So we can say here that core of transformer can become a soft magnet, because core of iron transformer is made up of iron over there. Needle of compass, that is a permanent magnet, that is hard material, permanent magnet over there. Iron fillings are used to show the magnetic field pattern, so that is also a soft magnet. So he is saying temporary magnet, so when in use, so it will be 1 and 3. 1 and 3, option C will be fine over there. Okay, here he is saying that students are asked to suggest factors that affect the speed of rotation of a direct current motor. The three of their suggestions are listed: the strength of the magnetic field, the current, the number of turns in the coil. Which suggestions are correct? Means the student are asked to the factors affect the speed of rotation of a direct current over there. So I will say here that all three options are 100% perfect. Like I can change the strength of magnetic field, I can change the current using variable resistor, I can turn the number of turns of the coil. So option A will be perfectly all right. All three factors can be going to use the effect of speed of rotation of direct current of the motor over there. If you increase all three factors, then any factor from all of these three, the speed of motor is going to increase over there. A transformer is used to power a lamp. Okay. So it is having less number of turns, it is having greater number of turns. And this is step up transformer, by the way. There are more turns on the secondary coil than on primary coil over there. Which statement is correct? There is an alternating current in the primary coil and a direct current. Never. Always on both sides there should be AC. There is a larger current in the secondary coil than in primary coil. No way. Because voltage can be larger in step up, but current will be smaller. There is a changing magnetic field in the iron core. Yeah, this can be possible also over there. And in the last one, he is saying in the iron core, there is an alternating current from the primary coil to the secondary coil. In the iron, there is a primary coil, in the secondary coil over there. Then I will say here option C is most suitable for this one. There is a changing magnetic field in the iron core because of the step-up transformer, which is most reasonable according to the transformer over there. In an electrical field, beta particles are shown. Okay, beta particles are shown. Which path does alpha particles traveling at the same speed flow over there? So I will say here that as the alpha particles are available, so just exact likely beta particles, they should not show deflection like that. They should show little bit less deflection over there. So option B will be perfect, that it will be if it is positive, 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 positive because of these beta particles over there, then it should be alpha particles should be on opposite sides having negative, but they should not show so much exactly equal deflection as like beta particle. It will show less deflection. So option B will be most suitable answer for it. C is for gamma, D is for, again, I can say beta, that should be the ion with the larger size of charge over there, or less size of mass than beta particles over there. So option B is 100% perfect for this answer. Which road gives the sign of the charge on the nucleus of an atom and the sign of the charge on an electron. Okay, nucleus is having protons and neutrons over there, and the sign of the charge on electron will be negative. So negative and negative is present over there, that they are being going to show in both cases over there. Then I will say the nucleus is having the number of protons over there, so they will have be positive. So option D is perfect for it, because the nucleus is having protons and neutrons as a tiny nucleus. They are showing the positive charge because of the presence of protons, and electrons which revolve around them can be taken by that value over there. An isotope has a half-life of 6,000 years. How much time passes before the count rate due to the emission from a sample of the isotope decreases 1 by 16? So it will be going to be taken according to the formula 1 over 2 power n. And if it is 1 power 16, so it means 1 over 2 power 4. 4 half-lives have been passed away. So 6,000 multiplied by 4 will give us 24,000. So 38 answer number will be going to correct for option C over there. Okay, this is the half-life which I use for that formula over there, 1 over 2 power n. Okay, what is an approximate time taken by light from the sun to travel to Earth over there? It's approximately equal to 50 seconds, but how it comes, I just tell to you. Like speed of light is taken as, we can say, 3 multiplied 10 raised to power 8 meter per second. This is the time speed, and the distance which is we will have to take from sun to earth for the light to reach is 48 point something the time over there, which should be coming over there. So distance is being taken as 9.15 multiplied 10 raised to power 15, and that is for one complete light year over there to be taken. And if I go for calculating the time to calculate the distance, then I say that is approximately 50 seconds. No, it is 500 seconds. How I will say it is 500 seconds? If I divide it by 500 divided, approximately 8 minutes and something like that. So 500 divided by 60, if I go for that, for getting in minutes over there, that it is 8 minutes and some seconds over there. 6, 8, the 480 and divided by 2, 0, because of decimal is 0. So 8 minutes, and then we say 62, 60 with the 3, 8.3. So 8 minutes and 3, like 20 seconds. So that will be 500 seconds as the correct answer for you. Option D, C is not going to be discussed over there, because 50 seconds is not possible. The light to travel from the sun to earth over there. Where in the solar system is the asteroid belt? Between the sun and the Mercury, and between the Venus and Earth, between the Mars. So asteroid belt is present between the Mars and the Jupiter. This is just like an information. If you have thoroughly studied about the solar physics over there, then we can say it should be taken over there. So this was your today paper. I will suggest you kindly subscribe my channel for getting more solutions of such type of papers of O Levels, IGCSE, IGCSE Edexcel, and A Levels related to sciences and mathematics. Thank you so much for today. Bye bye. Allah Hafiz.